Okay, so here's another style of trig applications question you might get. So remember last one we did cos 5 theta. This one's actually based on cos to the power of 4 theta and getting an expression for that. So it's set up slightly differently, and usually there's some scaffolding to it. So we'll go through this question. If z equals cos theta plus I sin theta, show that z plus z to the minus 1 equals that. So that's the first part we've got to do. And then we've got to find an expression for that in terms of these things. So our solution, the first thing, let's work on this. Now we know z equals cos theta plus I sin theta. And z to the minus 1 is going to be cos theta plus I sin theta to the power minus 1. Now by de Moivre's theorem, that's cos to the minus theta plus I sin minus theta. Now you know that the cos of minus theta is the same as cos theta, and you know that sine of minus theta is the same as minus sine theta, so it really just brings a negative out the front. So what that means, therefore, is that z plus z to the minus 1 is going to be equal to this plus that. So we go cos theta plus I sin theta plus the cos theta minus the I sin theta. We add them together and we get 2 cos theta. And that's what we're asked to prove. Because I've got a cos 2 theta and a cos 4 theta here, I know that I'm going to be looking at this as well. I know this, but with a little bit of practice, you'll probably be getting used to doing this process as well. So let's have a bit of think about z squared and z to the minus 2. Now, z squared is really just cos theta plus I sin theta squared. And z to the minus 2 is cos theta plus I sin theta to the minus 2. Now, by de Moivre's theorem, this is cos 2 theta plus I sin 2 theta. That's plus. There's nothing there. Plus now this becomes cos of minus 2 theta, but we've already seen that we can change it very quickly. So it's a cos 2 theta, and this will become a minus I sin 2 theta by the same process as what we did up here. Now if we add these together, that cancels with that, and you end up with 2 cos 2 theta. Now you'll notice the pattern starting to occur. So when this is a power of 1, we have only 1 theta there. It's a power of 2, we have 2 theta there. You can even then jump into something like z to the power of 4. And the reason I'm doing z to the power of 4 is because we need a cos 4 theta is equal to 2 cos 4 theta. Now you can do all that and show yourself that, but I think once you've shown a pattern, I'm pretty happy for you to go straight to there. Okay, so let's think about how I can get a cos to the power of 4 theta out of some of this. Now we notice we've got a cos theta here. So if I raise this to the power of 4, I should get a cos to the power of 4 theta there, or cos 4 theta there, not 4 theta, cos theta to the power of 4. So the way I'm going to raise that to the power of 4, I'm going to raise this to the power of 4. So z plus z to the minus 1 to the power of 4 equals 2 cos theta to the power of 4, which gives you 16 cos to the power of 4 theta. Now that seems nice, but what I need to do is I need to get this in terms of cos 4 theta and cos 2 theta. What I'm going to do is I'm going to consider the binomial expansion of this, sort of very similar to what we did in the last question. So z plus z to the minus 1 to the power of 4 equals, so expanding this by binomial, we get z to the power of 4. Remember it's a 4 there, so I'll just get my coefficients. So here's my coefficients up here, 1, 4, 6, 4, 1. So it's z to the power of 4 plus 4 z cubed, that one there raised to the power of 1, so it's just a z to the minus 1, plus a 6 z squared, because that's a 1, that to the power minus, or that to the power of 2, which is z to the minus 2, plus 4, it's going to be the z, and z to the minus 3, because that one's cubed, and the last one is going to be a z to the power of minus 4. Now what I'm going to do is I'm going to group some things together, because I've got some expressions up here that I'm going to use. So we get z to the power of 4 plus z to the minus 4 plus a 4. We're outside of now. This simplifies to z squared. This simplifies to z to the minus 2. They both had a 4 in them, so I took that out as a common factor. And these two cancel each other out, so I get a plus 6. So what do we end up with? We end up z to the power of 4 plus z to the minus 4. Now that's equal to 2 cos 4 theta, which is great. This here is 2 cos 2 theta times 4 gives you 8 cos 2 theta, and we've got a plus 6. So just finishing it off, put that over So what have we got? We've got 16 cos to the power of 4 theta. So therefore, 16 to the power of cos 4 theta must be equal to, now because that expression is equal to this expression, we can say 2 cos to the 4 theta plus 8 cos theta, 2 theta plus a 6. You can take a factor of 2 out of all this, and then if you divide by 16, that will give you an eighth. We took a 2 out of that. That's a 4 theta. We took a 2 out of that, so that's a 4 cos 2 theta. And we took a 2 out of that, so that's a 3. And that's your answer. And sometimes, again, they might say show that cos power 4 theta equals that. Now, you might get asked to use it or do something with it. But for this question, that's all we need to do. Get an expression for cos 4 theta, cos to the power 4 theta, or cos theta to the power 4, I should say, in terms of cos 4 theta and cos 2 theta, which is there.